Hello everyone, welcome back to my channel, I'm Joe. God of War is an action-adventure video game released on 2018. Unlike previous games, in this new series, Kratos has the new ability to throw axe and pull it back, making a mechanic that feels and looks great. Today's project is based on this new feature. My goal for this project is to try and recreate a similar mechanic using Unity. Here are the steps I needed to follow. First, I need to work on the axe throw itself and move forwards while rotating. The axe collisions that makes the weapon stick to the ground. Then, I need to pull it back with a different speed. Axe will return its original position with a fast speed. Step 3. We will make several items and add animations for each item. Items or enemies will be destroyed or taken damage once they attach to the weapon. Also, we will fix the errors in the end. As always, I will leave obvious commands included in program to benefit the reader of my code. The link for the project repository is on the description below. You can download the starting project on my Google Drive. Also, all of the tips and assets you can find on my GitHub. Okay, let's get into it. So we have opened up Unity and currently we have something in here. We already have one dungeon environment by using tile map system. Additionally, there are some waypoints for enemy patrol. We have prepared one player game object with rigid body 2D, box collider 2D, and animator component. Inside the player movement script, we used rigid body 2D.velocity to control our player. Under player game object, there is an empty game object served as the weapon position. This will be the original position of our weapon. Also, we have prepared one UI canvas to display the health bar. The UI mode is workspace, which will behave as any other objects in this scene. This is our enemy game object. He can patrol between 2 points normally. Also, he can shoot to the player once the player is inside his attack range. As I said, you can replace these characters with a simple image without any preparation. In this project, we will only focus on the weapon feature and will not use additional script. Go to Sprite folder and drag the weapon into the scene. In order to view the weapon, we have to change the sorting layer and his order. I set the order in layer value as 5. Then drag this weapon game object as the child of our empty game object. Reset his transform position value. Create one C# script called weapon. Then drag this weapon inside the weapon game object. First, we want our weapon can self-rotation. The first private is a float number that is called rot speed. Serialized field is just used for showing a private variable's value on inspector. You can easily change the value like public variable, but no one can access this value from other script or places. Since we want our weapon can make rotation when we throw and pull it back, and stop rotating once our weapon has reached to the target position or return its original position. We have another Boolean variable that is called isRotating. We can create a new function called self-rotation. Inside this function, if the Boolean variable isRotating value is equal to be true, which means our weapon has the ability to make the rotation. We use transform.Rotate. The rotation is often provided as a Euro angle and not Quaternion. We can first use the rotate tool to see how to rotate the weapon. Our weapon makes a rotation in z-axis. So we can say transform.Rotate 0, 0, rotate speed multiplied by time.their time. We only have to change the z angle. In else statements, we don't want to have any rotations so that each parameter value is 0. Call this function inside the update function. Save the script and switch back. Set the rotation speed value to 1200 and press play. Now we can make the weapon rotation according to the Boolean variable. By the way, if you want your weapon rotate in clockwise, you can set one negative value as well. Then we want our weapon can throw away and move forwards. Finally, reach to our mouse position. We have another serialized field private float variables called move speed. Then we declare one vector3 type variable called target position. This target position variables will record where is our mouse position after we press the left mouse button. In other words, once we click the left mouse button, target position will be assigned to the import.MousePosition vector3 information. Inside the update function, once we press the left mouse button, our character is going to through_weapon function. We create a new function called through_weapon. We want our weapon position is equal to our mouse position. We can't say target position is equal to import.MousePosition because import.MousePosition reports the screen space instead of the wall space. So what's the screen space? For example, the bottom left of the screen or window is at 0, 0. The top right of the screen or window is at screen.width, screen.height. We used camera.main.ScreenToWoldPoint import.MousePosition, which transformed the position from screen space into wall space. Save this script and press play. Once we press the left mouse button, our weapon will appear immediately on the mouse position in the scene. However, the result did not work out as well as expected in the game view. We can't see the weapon. Why? We can toggle to the 3D view and find the result. Our weapon position Z value is negative number instead of 0. We can drag our camera to check it. You will notice that our weapon can be seen on the game view. So we cannot directly say our weapon position is equal to camera.main.ScreenToWoldPoint import.MousePosition. For this work, we have to change the position Z value to 0. We want our weapon make rotations when we throw this weapon. Its rotating Boolean variable is equal to Q. Then, we want our weapon move towards the target location in each frame. Transform.Position is equal to vector2.Move.Towards. There are 3 parameters on here. The first parameter is our current weapon position. We use transform.position. The second parameter is our target position. The third parameter is our move speed multiplied by time.their_time. We can move our target position this line to here. Once we click the left mouse button, we can record our target position for easy to read. Also, when we press the left mouse button, through_weapon function will only run once. However, we want our weapon can move forwards in each frame instead of only one time. We can move these functions outside of these curly braces. We have another Boolean variable that is called isClicked. The default value is false. Once we press the left mouse button, the Boolean variable will turn into true. If this Boolean variable value is equals to be true, we will run the through_weapon function. Bind to Unity and set the move speed value to 10. Once we press the left mouse button, our weapon will move forwards that position with a self-rotation. Cool. Then we want our weapon stop rotating when the weapon reaches to the target position. We can go back to the editor and say, if the distance between the weapon and target position is less than 0.01, which means our weapon has reached to the target position, the Boolean variable's value is rotating is equal to be false. Save the script and check it out. Nice! Now our weapon can lock stick to the ground. We want our enemies take some damages once our weapon hit on him. We use onTriggerEnterToD function. If the object enter the trigger's collider tag is enemy, our enemy will decrease 25 points each time. I have attached the health bar script on the description below. If you want to know the detail, you can watch my previous episode. Bind to Unity and add the box collider 2D component for our weapon. Make the checkbox is trigger as well because of onTriggerEnterToD. Press play. Something wrong here because Unity cannot get the health bar component. The reason is that our health bar script has attached to his child game object instead of the enemy game object. We have to replace the get component with GetComponentInChidlren. Save the script and switch back. Now our weapon can take damage to the enemy. Once our enemy touches this weapon, he will lose 25 health points each time. However, we don't want our weapon takes damage when the weapon has stick to the ground. We have another Boolean variable that is called isDamage. When our weapon has reached to the target position, isDamage is equal to be false. Once our weapon has hit the enemy and isDamage Boolean variables is equal to be true, we will allow our weapon to take damage to the enemy. The AND operator is used to combine two expressions. Both expressions must be true for the entire expression to be true. Inside the throw weapon function, we set isDamage to be true. Bind to Unity and test again. Now our weapon will not take damage when the weapon has stick to the ground. We want our character can pull the weapon back, and once we throw this weapon, we cannot click second times and change its target position. After throwing the weapon, when we click again, our weapon will return its original position with a fast speed. We can leave obvious comments included for easy to read. We have private transform type variable called playerTrans. Inside start function, we use findGameObject with tag to get access of the player game object. Don't forget to get component of the transform type as well. The player tag must be declared in Tag Manager before using it. We have another private Boolean variable called canCallBack. When our weapon has reached to the target position, canCallBack is equal to be true. We can create a new function called bankWeapon. We want our weapon can return its original position with a fast rotation speed. Rotating is equal to be true. Also, we want our enemy move towards the player location in each frame. Transform.Position is equal to vector2.Move.Towards. There are three parameters on here. The first parameter is our current position. The second parameter is our player position. The third parameter is our move speed multiplied by time.their time. In order to receive a faster speed, we can set the move speed multiplied by 5. If we press the left mouse button and canCallBack Boolean variable value is true, once these two conditions are true, we will call this function. Also, we want our weapon takes damage when the weapon during the process of coming back. As I said before, getMouseButtonDown can only run once. Well, we want our weapon can come back in each frame. So we create a new Boolean variable that is called returnWeapon. Once we press the left mouse button and the canCallBack is equal to be true, returnWeapon is equal to be true. If the returnWeapon is equal to be true, we can call this bankWeapon function. Save the script and press the play button. When we click the mouse button, our weapon can move towards to the target position. When we click again, the weapon will return to our player current position. Cool. However, when we try to throw this weapon again, nothing happens because we did not continue to achieve. Also, we don't want our weapon rotating when the weapon is back. So we can say if the distance between weapon and player is less than 0.01, which means the weapon has come back. We want our weapon stop rotating. Also, turn off the canCallBack so we cannot call this bankWeapon function. Return weapon value is set to be false. Also, we don't want to take any damages when our player holds this weapon. When we press play, we can see our weapon looks weird and back and forth. The reason is that when we press the left mouse button and call the weapon back, we also ran the first import part which we don't want. In other words, sometimes we press the left mouse button and call these two parts. We forgot to set another conditions inside these if statements. If its click is false and press the left mouse button, its click is equal to be true. When the weapon has come back, its clicked is equal to be false. When we press play, it looks better. If you want your weapon always keep the right directions when it's back instead of the random rotation, we can say transform.rotation is equal to the new Quaternion 0000. We want to make some camera shake and particle systems. Let's create a new C# script called camera controller. Drag this script into our main camera. I'm going to quickly cover this script in this video because I have talked about before. In order to follow the player smoothly, I use vector3.lerp. The first parameter is our current position. The second parameter is our player position. The third parameter is the smoothest speed multiplied by time.delta. Also, I set the limitation of the camera movement. For camera shake, I set two private variables to achieve. Once this is shaked, Boolean variable is to be true. Our camera transform position will change. I have created one public function called camera shake. Once we want to have camera shake effect, we can call this function in other script and set the Boolean variable to be true. I have left the comments for easy to understand on here. Go to weapon script. We have one private camera controller type variable called camera controller. We use find object of type, which returns the first active object, the camera controller type. Once our weapon hits the enemy, we want to have the camera shake effect. Set the isShaked Boolean variable to be true. Also call the camera shake function. When we press play, now we can receive more feedbacks from the game. Also, we want to make some visual effects in this game. Go to Effects folder. I have prepared some sprites for effects. We can slice the sprites and create several simple animations. Make this as a prefab. Also, drag the destroy functions to destroy himself after 1 second in order to save the performance. Back to weapon script. We create two game objects variables called /effect and weapon return effect. Once our weapon hits the enemy, we want to instantiate the /effect. Inside the bank weapon function, once the distance between the weapon and the player is less than 0.01, we want to have one camera shake effect and the return weapon particle system effect. This time I use IEnumerator function. Set isShake value to be true and call the camera shake function. After 0.6 seconds, set isShake value to be false. Using star coroutine to call this function. Then instantiate the return weapon effect. I have made this particle effect as a prefab before. Making sure you have set the correct sorting layer order. Since I used the sprite, don't forget to choose to the sprites mode on here. You can customize your own particle effects on your project. Exit prefab mode. Select the weapon game object and drag each effect into inspector. Finally, let's create some destructible items. Go to Sprite folder and select the items sprite. Select the multiple mode and pixel per unit I set to 24. Then slice the sprites. Select the first 3 sprites to make the idle animation. If you don't find your sprite, don't forget to change the sorting layer. If you feel your animation speed is so fast, you can change the sample rate on here. My sample rate is 12. Then create another animations on this game object called box destroy. Then drag these 7 sprites into animation window. Adjust the sample rate for the better animation speed. Go to Animator window. Set one trigger called isDestroyed. Make a transition from idle to destroy. Select the connection line, uncheck the exit time, and set the conditions. We want this destroy animation can happen immediately, so that I uncheck the exit time. Add the box collider 2D component to this item. Create a new C# script called Destroy Item. We want to get access of the animator component to control the animations. Also, we want to have the camera shake effect. We get access of the box collider 2D component because we don't want our box has the collider when the box has destroyed. By the way, we still want to have the slash effect. On trigger enter 2D function, if our item touch to the weapon, we want to play the destroy animation. Then make one camera shake effect. Also, we don't want to have any box collider component anymore. Instantiate the slash effect. Uncheck the loop inside the destroy animation. Pay attention to here. Don't forget to set the tag weapon on weapon game object. Drag this box item as a prefab. Now you can duplicate this prefab and create multiple items using the same step. Before I published this video, I found one error. You can try to hold your weapon and closer to the item box. The item box will destroy even we did not throw the weapon. In order to solve this error, we can declare another public Boolean variable called isHeld. The default value is true. Go to destroy item script. When the item box taken damage to the weapon, and the weapon is outside of the player, which means isHeld is equal to be false. Inside the throw weapon function, when we throw this weapon, isHeld Boolean variable is to be false. Inside the bank weapon function, once the weapon return player position, isHeld Boolean variable is to be true. Alright, this is the end of this video. I will continue updating this project later and making code refactoring in the future. As always, the link for the project repository is on the description below. Stay tuned for future updates from my channel. If you have anything you want to see being made on a video, let me know in the comments. If you enjoyed this video, don't forget to like it, share with friends, and subscribe to my channel. This is much more to come. Thanks for watching, and I will see you in the next video.